Welcome to this video on graphing quadratic equations in vertex form. By the end of this video, you should be able to graph a quadratic function when given the vertex form of the equation and identify key characteristics of a quadratic graph such as the axis of symmetry, vertex, domain, range, zeros, and intercepts. Okay, at the top of our page here, I have until now been giving you the quadratic equation in standard form of ax squared plus bx plus c. But it's not always just in that form. We can see this in different versions of the equation also. This is called vertex form. And the reason it's called vertex is because the values h and k are your vertex. Okay, so h and k are the vertex, and your value h is your axis of symmetry. Okay, so the one thing that you have to pay attention to is notice this says this is a positive h, and I don't mean that every time you'll always have a positive x value for your vertex. What that means is in this parenthesis, this is x minus h. So really what you want to kind of look at doing is it's kind of like when we were solving before. So x minus h, you'll set it equal to 0. So to have that positive h, you just got to move the h to the other side. So this will always have the opposite sign of whatever it is in here. So if this is a minus, that will be a plus. If this is a plus, your x value will be a negative. So let's kind of look at this so you can see. So let's see if we can identify the axis of symmetry and the vertex for each of these. This is a duplicate, so we're just going to ignore it. So this is your h, this is your k. So remember, your vertex is h and k, and this is really saying x minus negative 9. So you really want to solve this. X plus 9 equals 0. So you subtract. So x equals negative 9. So your axis of symmetry is x equals negative 9. And then your vertex is that negative 9. And the k value is negative 2, so the y value is negative 2. All right, let's try it again. So this is a positive 1. So when we solve it, to get it to move to the other side, it actually becomes a negative 1. So my axis of symmetry, x equals negative 1. And remember, your x value of your vertex is the same as your axis of symmetry. And here's your k value. That's a positive 4. So it just stays positive 4. So now we know the vertex and the axis of symmetry. One last one. Go ahead and pause the video and try it all on your own and come back to see how you did. So I got an axis of symmetry of 10, because when I solve this, it's negative here. That means when I solve it, it's going to be positive. And then I reuse that number. That is the x value of my vertex. And the number right off the end, that's the k value. That's the y value of your vertex. All right, so let's just try a couple of these and actually graph them. So we can put them into our calculators just like we did a standard form equation too. So if you do not have your calculator in front of you, go ahead and pause the video to go get it and come back when you're ready so you can make full use of our time here. Okay, let's take a look. So our axis of symmetry is always going to be the opposite of what that number is. That's a negative 2. So our axis of symmetry is at positive 2. Our vertex is at 2, and my k value is negative 2. And so that's why they call it vertex form, because you can see the vertex in it pretty easily. So I have x equals 2. I'm going to go ahead and just put my axis of symmetry in here. I like to see it when I'm graphing so I know where my graph is centering. So that's x equals 2. I know my vertex is at 2, negative 2. I always like to label that. So now let's go into our calculator And we can put it in just like we see. We see 2 parentheses, x minus 2. Close your parenthesis, square it, and then minus 2. So always double check, does this look like the original equation? And this does. So I'm going to go look at the table of values to get some points to plot. Now, I don't really want to pick numbers way over here. I want to pick numbers right around that axis of symmetry so it's easy to see. So -1, 16, that's too much. 0, 6. I have room on my graph for that. 1, 2, 3, 4, 5, 6. It doesn't mean the graph ends. It's just it's gone off where we can see easily. So we have 1, 0. And then we had 2, -2, and that's our vertex, and you can see the quadratic pattern coming out from our vertex. Then we have 3, 0. And then we had 4, 6. So I'm going to draw this in. Remember to make the bottom curved, and then I'm just going to continue the line and put an arrow on it. Now that it's graphed, it's going to be a little bit easier to see the domain and range and the intercepts. So the intercepts, when we look at the x-intercepts, is where y is 0. It's easy to see here we got a y 0 there and there. Those are our x-intercepts. So they are at 1, 0 and at 3, 0. If we wanted to name the y-intercept, we could. It's where x is 0. So the y-intercept is 0, 6. It doesn't ask us that question, but we could answer it. And now let's look at domain and range. This is a non-world problem where the line's going to continue left and right. So we're going to say this is all real numbers. And our range is based off of where does the graph in relation to our vertex. The entire graph is above it. So all y values in the graph are going to be greater than the y value of the vertex because they're all above them. So they're all greater than -2. Okay, so let's take a look at this one. Let's notice there's a negative sign here. A negative sign in front of a vertex form means the same thing as it does for standard form. That means this graph is going to open down. So our axis of symmetry, this is -2. So when I solve it, it's going to become a +2. So I know my vertex is a +2, and then my k value off the end is +1. So I'm going to draw in my axis of symmetry. Okay, and that is at x equals 2. My vertex is at 2, 1. Now, I'm going to get some more points by putting this into my calculator. So I have a negative. It's not a minus sign out front. It's a negative. Parenthesis, x minus 2 squared plus 1. And always double check, does this look like the original equation? And now let's look at our table of values. I want to pick numbers right around that axis of symmetry so they're easier to graph. So I have -1, -8, 3, 4, 5, 6, 7, 8. And we can use symmetry here. This point is 1, 2, 3 to the left, so I'm going to go 1, 2, 3 to the right. Then I have 0, -3. This point is 2 to the left of the axis of symmetry, so I can go 2 to the right. And then I have 1, 0. It's 1 to the left, so I can go 1 to the right. Make the bottom of the graph curved. Okay. Now, let's see what kind of questions were asked. Our domain, this is non-real world. It's continuing on forever and ever, left and right. So it's all real numbers. Then we have our range. Look at the vertex. The entire graph is below the vertex. We know all the y values will be less than the y value in the vertex, which is 1. And our x-intercept, we saw them on the table. It's where y is 0. So 1, 0, 3, 0. We can see them both there. So that's good. That's easy for us to name. If they're not there, you're going to have to use the quadratic formula to figure them out. So, all right, hopefully this was helpful. Let me know if you have any questions. See you in class.